Hey everybody, welcome to the Airco welder part, I don't know, whatever part this is. Or maybe it'd be better to say, welcome to the land of confusion. So I decided that I wanted to hook up the Airco welder for TIG and try TIG welding because that was one of my goals that I wanted to get to. And then the other reason why I really wanted to hook this all up was because I wanted to see if after I hooked it all up, if I had any extra hoses that I might be able to use for my MIG welder, the Schematic. So I started to hook this up and I've been running into a couple of problems. When I originally bought this welder, it was set up for TIG welding in the guy's shop, and I basically unhooked everything so I could move it here. And I didn't pay much attention to how everything was hooked up at the time because I just figured that, well, it couldn't be that hard to hook it all up. And the weird thing, though, is that now I'm trying to hook this up and things aren't adding up. So let me see if I can give you an idea of some of the problems I'm running into. The biggest problem I'm running into is there's a bit of confusion here on my part, mainly due to what I'm seeing for labeling doesn't seem to coincide with what I'm actually finding out as far as where the hoses go. We've got two solenoids here. One solenoid is for gas and one solenoid is for water to the water-cooled torch. If you'll notice right down here, this says water in and out, and this says argon in and out. So that would make me believe that this is the gas solenoid and this is the water solenoid, and that this is the input connection on the water solenoid and this is the output connection. This is the input connection on the gas and this is the output connection on the gas. Here's the problem. These connections right here are very specific. This hose, for instance, okay, which is one of the hoses I have that I believe came with either this arc welder or my other arc welder, the other Airco that I scrapped. I can't remember if that came with any hoses or anything. But anyways, this hose right here, this connector, okay, first the hose is green, all right? Got two basic colors here of hoses. Well, three technically. Green, red, and then the black hoses that actually are on the TIG torch itself, okay? So anyways, getting back to this. This thread right here, okay, is a reverse thread. In other words, if I put it on this solenoid right here, I actually can't get it to screw in no matter how much I try, unless I hold it just right and I run it backwards. All right, so you see, it's the opposite of the lefty loosey righty tighty. It's a reverse thread. Okay, so the green hose will hook up to this solenoid. This solenoid supposedly is the water solenoid. So maybe green means water and the red hoses would be for the gas? Well, here's the problem with that. I'll show you why that doesn't make sense to me. This is the big old argon tank that I got with this welder. And along with this argon tank, I got this pressure regulator slash flow control and flow meter assembly. All right. And this hose right here is hooked up to it. This is exactly how it was when I took it apart. So I took it off of the tank. At least I'm pretty sure I took this off of this tank. And this hose was on here. So this hose, notice, is green. And if I follow this hose, down here, it goes to this connector right here. Okay? So far, so good, right? So I know this other green hose that I have, which just goes to another connector like this on the other end of it, okay, appears to be the same as this. And they do both appear to be, now wait a minute. So what's the thread on this? So this is coming from, yeah, hold on. See what I mean about the land of confusion? All right, so this is the one I just had on here, I believe. And with a little bit of finagling, I can get the screw in. Right, yeah. So this goes into here, it's reverse thread. This is the one from the Argon tank. That does not want to screw in there. Oh, let's see. So this, if it comes from the Argon tank and is not reverse thread, should go in here. Okay, all right, it does. All right. I could have sworn when I tried this earlier today that I couldn't get that to screw in. And that's why I thought I was having such a hard time hooking this up. Yep, that's going up to my tank right now. Okay, all right, so the Argon goes in here. Okay. And so then the Argon's going to come out of here, and it's going to go to the torch. So that's going to be, so the torch has 3 connections to it. It's got this green hose here, goes into this block. Okay, and then it's got these 2 black hoses here. The reason why it only has 3 connections is because gas goes into one of these lines and exits out the end of the torch and goes into the atmosphere. And the other 2 lines that aren't used for gas, one's a supply line for the water and one's the return line for the water. Which of these 3 is which, I don't know. But I'm willing to venture a guess that this green line here, because it's different than these 2 lines. These 2 lines almost match. So I'd be willing to bet that this line is the gas line. And if I'm right about that, then that would mean that the other end of this hose right here. Okay, so see, now that doesn't make sense because this is a reverse thread. So this wants to go to the water. All right, so if this green line is the water feed line to the torch, then when I blow into this, the air should come back out one of these lines. And that would mean that whichever one of these that the air comes out of is the return for the water, and that the one that no air comes out of is the one that's gas. Does that make sense? All right, so the memory card filled up there. So I still believe what I was about to do is I was about to blow into this green line, which goes into this big brass block, and then to the torch to see if anything comes out one of these 2 lines. What I hear is a little bit of bubbling and noise coming out of this one. So this is my return. Or is it the supply? I don't remember. All right, but I do know that this and this are connected to each other. So this is going to be for gas. And since the gas is real simple, comes in from the bottle in the regulator, goes through the valve and goes out to the torch. This has to go here. And by that token, this must be a reverse thread. And it is. Okay, good, good. All right, now I'm getting somewhere. All right, so now the next conundrum is the water lines. Okay, so I've determined that this is definitely one of the water lines and that this is the other water line. Now I know one of the water lines from the torch has to go to the solenoid, the water solenoid over here. And the other one is going to have to go to the water cooler. Since this is a long hose and this is a very short hose, it goes without saying that this is going to have to be the one that goes over to the solenoid. Now, the problem is I don't know whether or not this hose is supposed to go to the output of the solenoid or the input of the solenoid. I mean, obviously the reason why these are marked in and out is to denote the direction the water is going to be flowing. So according to this, the water is going to flow into the solenoid, and when the solenoid opens, it's going to flow out here. So you would think, oh, well, it's going to flow out to go to the torch. But wait a minute, what if this is the return from the torch? Then we would want this on here. And I got the same problem up top. There's an in and an out on the water cooler, and I don't know yet which one of these should go where. Now, what I do know, based on the diagrams I could find online, just for, in general, how to hook up a water-cooled torch, almost every one of them shows that the water should come from the cooler and go to the torch, and then return from the torch to the power block connector in almost all of those applications, which would tend to make me think this is a return line. Okay, so if this is a return line, then this is going to go to the input on the water cooler, and then I'm going to have another hose, the only hose I have left, is going to have to come from the output of the water cooler, and I guess it's going to have to go to the input of the solenoid, and then the output of the solenoid is going to go here. Okay, this must be it. Oh yeah, that's right, this is reverse thread. Okay, and then I got one hose left. Oh, interestingly enough, I have two hoses left. So I have an extra hose, which I'm going to use more than likely on my MIG welder. What is this hose that I have, though? This hose is, I don't know. I know one of these wants to screw on, so these are both right-hand thread. These must be, I mean, these are probably both right-hand thread. All right. Oh wait, I got another hose here. So I got two more hoses. These must have came off of that other Airco welder I got. So let's see. This is going to be. All right. So that one will screw onto there. Just for the heck of it, I want to see if this red one will. Nope. All right. Well, it's going to have to be this green hose. So again, since this is going into the solenoid, this is going to have to go to the output on the cooler. And drop this down below. Out here. Okay, so we've got coolant in here, comes out of the output, goes through this hose, and enters the water solenoid here. Okay? When we energize the torch, the solenoid opens, and the coolant flows through this line directly to the torch head. The returning water coming from the torch head comes via this line into this power block, and then returns through this line back up to the input on the cooler. All right, and that, I believe, is the correct way this is supposed to be hooked up based on what I was able to find online. Now, if you're watching this video and you're using it as a reference to try and figure out how to hook up your own cooling system, I would warn you that you don't necessarily want to listen to what I'm doing because, for instance, I know based on the manufacturer's website that this particular model of Dynaflux gear pump cooler has a built-in bypass system to the tank. So what happens is there's actually a valve inside, and what will happen is if the output is blocked, which when the solenoid down here is not energized, when this valve is closed, this is basically its deadheading. It's a deadhead. Not like a fan of the Grateful Dead, but my point is that the water's got no place to go. So the pressure backs up in that line, and it causes a valve to open, which will allow the output pressure of the pump to be diverted and dumped right back into the tank. Okay, and that's protecting that pump. If you do not have a cooler that has that provision, and you hook the output of the cooler up directly to the solenoid like this, when the solenoid is closed, the excessive pressure buildup can actually damage your pump. At least that's what I've been led to believe based on what I've read. So I should be all set. I just got to tighten up these connections, top off my coolant, and then I got to deal with some electrical issues down here. Okay, so here's my little electrical issue, so to speak, that I have to sort out. Over here on this side, inside the bottom access panel here, are these big lugs, okay? And they're marked. This bottom one has a sticker above it that says metallic. This middle one has a sticker above it that says tungsten inert gas. And then there's this one up here. Either that or this one's the tungsten inert gas, this one's metallic, and this one is unmarked. Not quite sure. Now, on most of these units, again, we're talking about the Airco Model 3A, also known as the Miller Model 330A/B/P, I think. But anyways, on almost all of these that you find online pictures of, and almost all of these that you find online manuals for, they all have, in this area right here, a knife switch. And the knife switch is described in the manual as a balancing resistor. Obviously, it's not a resistor itself, but what it does is, depending on what position that switch is in, it apparently switches in circuit a balancing resistor somewhere behind there. And that is what determines whether or not this unit is in stick weld mode or TIG mode. So even the knife switch, if it were here, there's a little bit of confusion about the knife switch, because some manuals say that it should be in the up position for TIG welding, and other manuals say it should be in the down position for TIG welding. And the reason why is apparently during production at some point in the whole life of this whole line of welders, they did some changes. I think they switched some things around. So you don't want to get into, if you have one with a knife switch and you're wondering what the heck you're supposed to do, you don't want to get too tied up with the up or down position, because you might find that that's not correct. What you really want to know is you want to know open or closed. The beauty of the knife switch models is that there's basically only two connections, and when the knife switch is in one position, it makes two connections, and it makes a connection between the metallic and like a common lug that is the pivot point for the knife switch. The other orientation of the switch actually causes the switch to be open, essentially. It's an open circuit, and that would be for TIG. So it's open for TIG and it's closed for stick. All right. My problem is I don't have a knife switch. So what I had on here that I already removed is this big copper strap right here. Now this copper strap was like this. This was on here, and this was swiveled up and locked into there. So essentially this one that says metallic was, well, again, I'm making the assumption that this sticker is for this one. This one was shorted to this one. And if you look, you'll notice these are large diameter lugs. Just like that hole is large diameter, that slot is large diameter. Okay? The weird thing is, this one up here is a very small diameter screw. There doesn't appear to be any way for me to actually, like for instance, I can't use this strap to really effectively short this to this even if I wanted to. And I don't think I'm supposed to. I actually think that much like the knife switch in the open position is for TIG, I think removal of this strap sets this up for TIG. Except for one thing. If that's the case, why does this exist at all? Why do you need this even here? So that's where I'm a little confused. Well, guys, looks like the answer to my question is right there in front of my face. There's the original schematic, and what I did, because it's kind of hard to read, is I blew it up. I took a picture of it with my phone, and I found where that switch or jumper is located in the circuit, and I enlarged it. And you can clearly see there's 3 posts right there, and you can see that they're showing that where it says metallic, there's a dotted line, so that's showing where the jumper should be in metallic position or stick weld, and above it you can see that's where it should be in the inert gas, so they're showing it in the inert gas position. You'll notice that there's electrical connections to the bottom post and the middle post. There's nothing connected to the top post. Therefore, when the strap is in position between these, when it's in these 2 positions across these 2 posts right here, it's completing this circuit. And when it's removed, there's no connection. That's the inert gas or TIG mode. So, to sum up, if you've got a screwy situation like I have here, you just remove any jumpers and it's in TIG mode. And if you want to put it back into metallic mode, you put a jumper from here to here, which is what was on here when I bought the machine. Actually, I think I put it in that position because I don't know what the heck was on here when I bought the machine. That's a good question. Because this was set up for TIG when I bought this. Yeah, anyways. All right, so that takes care of that. And if you have a knife switch, you want the knife switch to be in whatever position will cause the knife switch to be not making a connection to anything. So hopefully that clarifies that. All right, so I got one last thing I wanted to do on this before I put some coolant in my cooler and fire this thing up. And that is, I want to set these spark gaps to exactly what it says up here, which is 0.008, 8 thousandths of an inch. So this is real simple to do. All I've got to do is loosen these 2 screws, and this little clamping block will loosen. I can slide these out, put a feeler gauge in there, slide it in so that the feeler gauge is just lightly being grabbed, and then tighten them. But I noticed there might be a little bit of dirt or debris in there, so I'm going to take these out completely, clean the surfaces, and then reset them to 8 thousandths. Okay, now before I forget, I want to switch my polarity up here, because right now this is my polarity switch on this unit, and I've got it in reverse polarity. This would be AC, but for TIG welding, I'm not TIG welding aluminum. For TIG welding mild steel, I want DC electrode negative, also known as straight polarity, for old time welders. And this is an old time welder. Alright. And I'll worry about current range and all of that later. I've still got to hook up my foot pedal, put some coolant in the tank, and I got to rewire my plug, because I stole the plug off of this to test out that that big oven I was talking about in one of my previous episodes. Alright, I think it's almost supper time. I think I'm going to take a break for today. Just when I think I'm almost ready to fire up this TIG welder for the first time as a TIG welder in my possession. Get my camera wet, but we got a leak, and we got a big leak, and it's spraying out, and I can see, it's probably not going to show up on the camera because the light's not so great over here. There's a big split in this fitting, so go figure. I'd love to know how the heck that could even be there, because I had this on the bench couple months back or whenever that was, and was cleaning it up and test running it, put it all back together, and this thing wasn't leaking here, and now it's split. Well, the good news is it just seems like it's just a female coupling in brass. I might even have one of these somewhere in my drawer of fittings.